And we are live. If someone in the chat can let me know that they can hear me clearly, because sometimes I often leave off my mic sometimes when we get these things started. It's a little button I have to hit. But welcome everybody to our night of talks. We're going to have 3 exciting talks on very different subjects tonight. We are delighted to have non-TOG members present tonight, so you get a kind of feel of the wider maker community and what's going on in Ireland. So if it's your first time here and you've never heard of TOG, let me tell you a bit about ourselves. So we are a community-run hackerspace based in Blackpits in Dublin 8. Unfortunately, we're closed now due to the level 5 restrictions, but hopefully now in the next few weeks in May and June we can open as the restrictions ease. So we're a bunch of makers. We rent usually about 500 square meters. We've lots of tools. We have a wide range of interest from our members. Some are interested in electronics. Some are interested in crafting. We've got brewing. There's 3D printers, laser cutters. There's people doing radio experiments. All sorts of different interests are catered to, and you'll find an excited member there when you come and visit and tell us a bit about your interests and projects. So I have a few announcements before we kind of kick off. One announcement is, and I'm going to hide my face and this should work, is that the Dublin Maker Festival returns this year. It's going to be virtually held on the 19th and 20th of June. We're very proud to be one of the supporting organisations making it happen, and the open call is running at the moment until next Tuesday. So if you've got any ideas or projects you would like to showcase to the general public of Ireland and wider afield, please do put in your details into the open call. All the information you can find is on dublinmaker.ie, and don't forget that your project doesn't have to be finished. It's about showcasing the process, the thought, the craft, the design, and all the great fun that goes into making all sorts of projects. So have a think about your project and what you've worked on over the last year or so, and please do make a submission. TOG will be making a submission soon. Hopefully we'll be able to bring you some projects that our members have been working on. So I'm working on a kind of jumping interactive kind of carnival game. I know some of our members have been working on solar heating. We have people who are just interested in gold panning, and I'm sure they'll be able to talk to you about all the tools and stuff they've made for that hobby. We've a wide range of things that our members are interested, and we look forward to showcasing them to the public at Dublin Maker. And then the other announcement I have to make is we are having a live Q&A at the end of all 3 talks tonight. So do use the YouTube chat there, put in your questions, and I'll be putting them to all 3 speakers at the end tonight. And we should have a bit of back and forth and have all your questions answered. So now I'm going to throw you over to Brian. He is a maker based in Cork who has a background in making instruments, and he will tell us all about his adventures with Uilleann Pipes tonight. So let me just flick my screen here. If I do it correctly, we should all see now Brian on the screen, and I've just unmuted him. And Brian, you're ready to go there.
Hey, nice one, Jeff. Thank you very much. Thanks for having me. Thanks to TOG, and thanks to Benchspace as well for putting this together. So yeah, I'm Brian Leach, and I'm a maker. I make musical instruments, and I make electronic musical instruments, and I'm a musician and a sound artist as well. So yeah, what I'm here to talk to you about is NAND gate oscillators, which are the type of circuits that I've been using to make experimental musical synthesizers like this. So here's one. So let me show it to you here. So this was a guitar, and now it is full of electronics. And basically, it's a really cool instrument to play because it opens up a whole world to you, because it's played in an unconventional way just by connecting the connecting the strings to plates on the top of the guitar and twisting all the knobs and everything. So it's really cool. And what I use to make those kind of circuits is actually really simple at the heart of it. It's this NAND gate oscillator. So what that is, it's a Boolean operator. So a lot of you might know about that. It's not and. So basically you have, I'll show you this. So I have a little circuit diagram to show you how simple it is. Hope you can see that. But basically it's got two inputs and it's got a capacitor and a resistor. And it's very easy to set up an oscillation because when the voltage goes high, it charges the capacitor, which causes the voltage to go low again, basically, by the way it works. So that's a CD4093 chip. So that's what I'm using for those. And it's super simple, like literally just those, a 9-volt battery, the little IC, and a capacitor and a resistor. And you get a tone out of it. So then you can do different and more interesting things with that. So what I'm really interested in as well, I'm kind of obsessed with Uilleann pipes, making Uilleann pipes and playing them as well. So I really wanted to kind of experiment with pushing things forward with that. Kind of like similar to the way I view it, like the way the electric guitar changed the way the guitar worked, and the electronics are a really important part of the guitar, the electric guitar, but it still is a guitar, you know. So basically I wanted to come up with the way to use to change the drones on the Uilleann pipe into a electronic version. So the Uilleann pipes are a traditional Irish bagpipe, and they're very complicated because they've got loads of pipes. So they're kind of the most advanced and the most evolved version of the bagpipe that I know of anyway. And here is a version of a set anyway. So this is the drones. These are the 3 drones of the Uilleann pipes. And basically their job, it's called a drone because it just plays one note. And there's 3 of them normally on a set of pipes. So you get a note, you get D, so it's just going beep, and then you'll get an octave lower as well from a longer pipe. It's going beep, and then you get an octave even lower again. So you have 3 octaves of the same note. And it sounds like, when you hear it, it's got this really distinctive bagpipe sound, but it also has this kind of hollow, almost electronic sound, I think, sometimes. And they say as well, it sounds like a beehive or the buzzing of a bee. But check it out. I've got them here, so I'll give you a blast of what the drones sound like on the Uilleann pipes. So that's it. By just playing with a constant pressure, you just get this one tone, and because there's 3 pipes and 3 octaves, it's quite a thick, nice sound, you know. So I thought it would be pretty easy to make an electronic version of this because, as I showed you, the circuitry for the NAND gate oscillator, you could just make one and tune it so it plays a D, and then make another one that's an octave lower and another one below that. And the 3 of them sound together, hopefully something like this. And the interesting thing is, like the sound in the Uilleann pipe drone, it's made by a reed, which is basically a little thing that kind of opens and closes like that, according to the pressure. And it actually creates almost a square wave as well, because the flow of air shuts the valve and that stops the air, which causes the valve to open again, and then the oscillation keeps going like this. And that's actually quite analogous to what's happening in the circuitry as well, where the voltage is causing it to rise. That's shutting a gate or a valve, and that's setting up the oscillation. So I thought it'd be pretty easy to make something that might do this, and it would save me pumping the bellows harder. You know, you could just jam along with the electronic device. So I made this. Let me see if I can get it on the screen. So it's a simple little box here. It's got 3 of those oscillators in it, and it's got a pitch control and a volume control for each one. So yeah, when they're all hooked up together, I thought it would be pretty easy to make a sound similar to that in some ways, but it didn't really work out that way because I kind of do freestyle electronics, which means I don't necessarily have a full schematic when I start making it. I just kind of am listening to it as I'm soldering it, and I'm just kind of seeing what happens. So here's what happens when I first tried to tune it. I'll turn this on here and give you a listen. So yeah, that's not bad. It was kind of difficult to get it in tune like that, but I managed to get a sort of musical sound that could lie underneath a melody and would fulfill the same role as the drums. But it was quite difficult to kind of get it into tune. And what I found was that the different volume controls were affecting each other. The pitch controls were acting kind of strange, like one might affect the other. Somehow there was interaction between them. And I'd seen that sort of thing before. And the reason why it happens is that the different parts of the circuit are not buffered from each other. So what I've done in the past is use a op-amp follower, which just kind of buffers the circuit. And once you have one bit working correctly, you can say, okay, now that's not going to interfere with anything else you add on afterwards. But I didn't do that. And that's why it started sounding strange. But I thought, actually, this is kind of cool because it kind of is doing all these strange things, and you're getting sort of frequency modulation and amplitude modulation that are changing the tone, and it's starting to sound like you're tuning a radio. It's kind of experimental. So I thought that was pretty cool. So I might actually just follow that that idea and develop that further. So what I did as well, so I didn't add those buffers. I left it basically as it was, but I did add this one switch here, which is actually a special kind of switch. It's a double pole quadruple throw switch. So it's able to connect 4 different things at once. And I was glad to find an excuse to use it because I had that switch for ages in my box of electronics. So another thing you should do if you're ever doing electronics, they'll tell you that on your little ICs, on the little chips and the circuits you're using, you should tie any outputs or inputs that you're not using, you should tie them to ground, because that can stop unexpected things happening. And I had a notion that probably part of that was why I was getting this strange behavior out of this synthesizer box that they built. So that switch allows you to, I was thinking maybe it would allow you to have normal operation where it would just sound like the drone I wanted. And then you could go to kind of crazy mode where it would lift those grounds and allow unusual things to happen. But what actually happened, like I would call the 2 modes crazy mode and then just absolutely insane mode, because there's nothing really normal or expected was happening in the circuitry. So I'll give you an example of what happens when I can use that switch to make some experimental strange noises. So you start to kind of think you're contacting the aliens or something like that. So I thought this is really cool from a sound art point of view, because I like to make experimental sounds, and when you're playing an instrument like this, you just don't really know exactly what's going to happen, and that makes you kind of very present in the moment to just get sucked into the machine, and you're not sure, are you controlling it, is it controlling you, or what's happening? And that can be quite an interesting artistic experience. So yeah, I basically followed along those lines, and I'd like to kind of just encourage everyone else to experiment with those things as well, because it's not difficult to actually make those circuits. You know, you could make them even on a solderless breadboard, or you can solder the bits together. If you add the potentiometers, you can get some really cool sounds. And just the fact that those unexpected things happen, I found that you know, quite informative. And even some of the sounds that were coming through there, they seem to be analogous to the sounds you get when you try to tune the drone reeds in the Uilleann Pipes, because sometimes when the notes are close to each other, there's some like crazy stuff happens, and then just sometimes you get a wild note out of nowhere. So I think instead of building an instrument that was actually easier to play or tune the drones, I made one that was more difficult, probably. So I'm gonna maybe try and do it right and use those buffers and do different things. But I'm also interested in the sort of the idea of changing the reeds to work in a maybe electromechanical way. So you'd have them like working as a mechanical music making reed, but you'd be sensing the sound maybe using magnets, using coils, or using other kind of electronics to do that. So I'm interested to explore that idea. And yeah, I think it's just really an exciting time, because there's places like TOG and places like Benchspace and other maker spaces all around the world that are opening up the knowledge of how to experiment with these things. And yeah, I really see that as a sort of invitation to like go and play with those things and like join the club, you know. So yeah, I'd like to just invite everyone else to also do that, and it's really good fun. So that's basically what I've been working on, and thank you very much for listening. I'll pass you back to Jeff.
Thanks very much, Brian. And when you have two modes on your instrument, one called crazy and one called insane, I'm sure it makes a lot of fun to play it. So if anyone has any questions for Brian, be sure to put them in our YouTube chat line, and we'll be speaking to him again at the end along with our other speakers. Thanks, Brian.
Thank you.
So I am going to switch you all to a slideshow of recent projects that our members have completed while I set up the video call for our next speaker. I should be back in just a moment. So we are ready with our next speaker. Up we have Bobby, who's going to talk to us about the Sharepair project and the work that he's doing on all to do with right to repair and the various other activities of the project. So next up we have here is Bobby. You're now live.
Hi everybody, how's it going? I'm just going to share my screen here. and take you through the Sharepair project. So hopefully you can all see that.
Yeah, we can see your screen.
Okay, great. So I'm Bobby Comerford. I'm a researcher based in UL, and we're working on a project down there which is to do with reducing the issue of e-waste in Europe. So just to give you an overview on the EU e-waste statistics, it's one of the fastest growing waste streams across the world, and in Europe particularly, it's 3 to 5% annual growth. So we're looking at 53.6 megatons globally per year. And again, it's the 3 to 5% growth per year as well. And there's a number of factors for that, really. So it's a high consumption rate for electronics, short life cycles, which everybody knows through the irksome feature of inbuilt obsolescence. And then also there is far fewer repair options available for those that actually want to, and particularly for lower price points. So if we look at kind of closer to home on our WE collection statistics, you can see that these are positive statistics for we.ie, and they're collecting a huge amount, but there's a small issue about how recycling and tearing down these products also has a carbon footprint. And indeed, some of these products that they're already collecting have useful life in them. So there's a third of all material that comes to recycling centres and civic communities that actually has some life left in it. And then there's 25% of electronic waste that is significant reuse value. So if there was a bit of repair involved in some of those items that are collected, we could really reduce the amount of waste that we're building as a society. So the Sharepair project wants to deal with these issues. We want to look at the issue from a number of different points. There's the community repair aspect. So there's a whole community for repairing things already in existence, and we want to create supports for those. We also want to support citizens that want repair. So citizens that may not have already thought of repair, but they need to be presented that repair is actually an option to them. And in addition to that, we're looking at developing tools to help both citizens and the repair community, but then also to kind of tidy up and maintain the data space that we collect data on the activities in repair across Europe. So here's some of the project partners that we're working with. Some of these are kind of big ticket names, definitely in the area of repair and research in general, but you might know Restarters or the Open Repair Alliance, who are partners in the project and helping us kind of to meet these aims. So these are some of the things that we're doing in this topic. These are the mock-ups, the super early prototypes that we have for the digital tools that we're developing. And so where there's a 5-element approach to the project. And what we have and we are implementing is basically a cities platform, which is about disseminating the idea of repair, a mapping tool which will help show people what repair services are available, whether they're professional services or citizen-led services like the repair cafes that are spread throughout Europe and the world. Then also we have a repair guidance tool. So that's what that is really a decision-making tool. So if you or I decide that we need to repair something, we might be able to get instruction on whether it's more complicated than we would dare to attempt, or if it's within the parameters of what we might try, and then give us some sort of supports as we try to self-repair. We also have a 3D printing parts library that we're working on. And so that's TU Delft. We're working on mapping out the feasibility of using 3D printing to repair parts for electronic items. And then we're also kind of tidying up, as I mentioned, the data space so that we can use the data more readily. So this is what it looks like so far. People are already working in this area of repair. There's 10,000 plus volunteers in Europe already working to help people repair their items. And they're already making big impact. This is last year's statistics for the repair logs. So not all repair logs are repaired items, but there's a high likelihood for the electronic items to actually be repaired once they're brought to a repair organization. And we can see the figures here. And so it all looks great, and this is what an actual repair cafe looks like. So we have something like a local pub, a whole load of potential landfill that people desperately love and they want to repair. And so then we have anxious owners that may have data on their devices that they really need back, or it might be even just a Hoover or vacuum cleaner that they would rather not throw out and they felt that they could hang on to for a bit longer. And then we have these seasoned fixers who are volunteers that want to help people and share their expertise. And there's an exchange really with the owners or the product or device owners that bring the devices to the events. And they learn as they're there, and they can maybe carry things forward and learn more about their device and possibly enact some sort of repairs if they're needed in the future. But people bring their one of the main things about this area is that it's fun, it's welcoming, and it's informal, but then it's also chaotic, inconsistent, and it lacks any kind of formal structure. So data collection in this environment is tricky, to say the least. But the people bring their devices and they get a repair, and we get data from it. So we get things like this, which is an infographic based on the data set that Open Repair Lines release. So the Open Repair Lines is a conglomerate in a way of international repair cafes, and they all pool their data together to give it more power, so that we can get more statistics and use those statistics for lobbying for change. So what we get is a diverse range of information about how products fail, what products people want to keep, and what things are easy to repair and what things are not easy to repair. So this latest published set of records is almost 50,000 records of attempted repair logs. So it's a great data set to use, and it's not the most voluminous data sets out there, but it is citizen-led activity that it has substantial kind of data behind it. So if we already have data for it, what's the big deal? The issue is, I suppose, that this is what data collection looks like at the moment. It's not exactly efficient, and there's a huge amount of cleaning that needs to happen before we can get anything usable from it. And so we need to, within the context of the Sharepair project, we are kind of formalizing the data collection methods and the data space so that we can use it to integrate with other things. So this is ultimately, after the whole lot of cleaning, this is what the data can look like. It can give us impact. It can give us things like the amount of items, the amount of waste prevented, the CO2 emissions prevented, even things like volunteer hours, which can be significant when speaking to government. So they can also tell us how things might fail, what things fail. Do we need parts for something? Can we build a searchable database on common faults or repairs? What's the life cycle for most products or products within a particular category? And to a certain extent, we can get information on who wants to repair and what they want to repair the most. So this is what we're doing to kind of support this whole area. We've built several kind of apps and tools that were based on interacting with citizen-led volunteer organizations. A lot of kind of hours speaking to what their needs are and trying to figure out what it is how we can assist them in their objectives. And ultimately, everybody's objective is to aim towards something like this. Really, it's something akin to the Green Deal, the Circular Economy Action Plan, and the Right to Repair. It's the French Repairability Index, which is an index that was recently implemented by the French government. It's a government level legislation, which means that anybody selling electronic devices, smartphones, laptops, televisions, washing machines, and lawnmowers. There was a time when washing machines were not electronic devices, but now they are insanely complicated. But there was a time. These repairability indexes are mandatory to be on every electronic device. And whilst it doesn't make the items any easier to repair, it does give consumers more power about choosing something that they may need to repair in the future. The repairability index is built off 5. You can see the categories there: documentation, disassemblability, and then availability of spare parts, price of spare parts, and product-specific aspects, so things like tools and things like that. And so they're given equal weighting, and it's a self-declared score from each company. So that's how that index works, and it gives power to the consumer. And so how can any of us get involved in the idea of repair? So we can look at the items that we frequently buy, and we can track back the resources that those items are dependent on. So this map here, is Source Map, is an initiative which shows the extent of this is the resource dependencies of Fairphone, which is a project which is built with a low environmental impact in mind. So if we can think of this as what our minimal feasible viable product is for an environmental phone, we can imagine what the standard is, or a common instance of resource dependencies might look like. So it's much more advanced. So resource map is a great way to learn about how our items are dependent on different resources. And we can look at something like this project, which is a Material Matters project, which looks at all the critical raw materials that are actually in the devices that we use. This is an instance of a linear life cycle of a typical smartphone, where it's an interactive map where we can track how the resources are mined and then manufactured and maybe used and then disposed of. So it's a great way to get a kind of handle on what is involved in a single life cycle of a typical electronic device. And then to get really hands-on, I suppose, or to not get physically hands-on, but to some degree, you could get involved at Restarters. And Restarters are one of the repair cafe kind of bigger organizations in the UK they make up part of the Open Repair Alliance data set. And they need to clean a lot of that data that they scrape off whiteboards and make them machine readable. So they've developed this portal where we can just log on. You don't have to have login details or any electronic knowledge, but you can help sort through the data and make sure that it's more usable, and they make it quite easy to do so by assigning tags to it. The next thing that we could do is to actually volunteer or join up with the Right to Repair movement and actually sign the petition to join the Right to Repair, which adds more, which bolsters their impact with numbers. And closer to home, I suppose, on the island of Ireland, there's the Community Reuse Network Ireland, which has a brilliant resource selection of resources on their website about how to repair and reuse both electronic and non-electronic items. And then there's the Monaghan County Council led project, which is repairmystuff.ie, an amazing resource really for anybody who wants to have anything repaired. 800 plus businesses are on this site, so if you're looking for something to be repaired, there's more than likely a listed repairer on this site. And it's a project that was undertaken by Monaghan County Council with the local authority waste prevention network, along with the EPA. So it's brilliant. It's a really great resource. And then what else we could do is to go to iFixit. iFixit has a massive database of repair guides. If something like an Xbox controller or your whatever it is, your phone is broken and you think you can do it, you think you can repair it, then the repair guides are brilliant, as they will help you through the process. And why not document it and share it on a social network to show that repair is an option. And then the final thing you could do is actually set up a repair cafe. So repair has gone remote, and it's also gone international. So Repair Connects is the repair tool that we've developed within the Sharepair project, which helps people to still connect with one another and connect with people who need repairs, and then people who have electronics expertise, or they have experience in repair. They can actually connect with these people and help them repair their devices, so that they don't need to throw them into landfill. So this is a kind of primer on the Repair Connect site that's live and is already taking on repairs and dealing with repairs across Europe. So that's what we promote, and hopefully people can get involved. And though we can't meet physically, it would be really brilliant if everybody was able to still share their knowledge in repair. Okay, thanks.
Thanks very much, Bobby. You had lots of interesting resources there, and I'm sure people will be checking them out. And if anyone has, I see some questions are coming in on the chat line for Bobby, and we will get to them later on at the group Q&A. If you've got any more, please stick them in. So I'm going to switch you all now to our slideshow while I set up our next and final talk, where it's going to be Louise and I talking about the electronics in an escape room. We'll be back in a moment. Sorry for the delay, folks. We're just fixing some technical issues and why Louise's webcam suddenly won't start in the video chat. But while we're waiting, I will tell you about some of the projects we see on screen at the moment. So the one that's currently on screen is a casting project for a lapping plate. I didn't know what a lapping plate was when a member sent me the photo, but it's for sharpening instruments. Next up here we have some 3D printed mounting points for Shelly. They're an IoT device for remotely controlling your power and monitoring power usage. Then here we have is Gary trying to fix his tire. And I will leave you enjoy the rest of the photos while I get Louise's webcam up and running. And thank you all for waiting. We're going to jump right in now to a talk from Louise and myself about some fun and bringing an escape room to life. Go for it, Louise.
So this is a really enjoyable and somewhat stressful project because of the time pressure on it. But it was a pleasure to work on. Really nice to kind of get some really well made props and add some Arduino to them. I'm going to just throw in, I'm not a engineer by any means. I'm a designer, maker, and I'm self-taught with Arduino. So I reached out to Jeff and some other members of TOG to help out on this. And you'll see Brendan and Ben, they're on a very late night in TOG, a very busy late night. We were all kind of trying to pull it together. Like the bulk of what went into these props is really simple stuff. It was just I think it's like with Arduino, generally, there's a lot of fiddling around. It's a prototyping platform and nothing is ever straightforward. And I think one of the difficulties was trying to communicate that to the client. They had a sort of expectation that it was very plug and play. And it isn't, let's face it. So the bulk of what we used was just sort of reed switches and Hall effect centers, and there's a lot of LED, just basically creating lighting effects in the props.
Louise, do you want to tell the viewers the general theme of this escape room, and maybe some because we're all seeing the different props on screen, they might know how they all stick together.
It was just to say, this escape room is not in Ireland. It's not in Dublin, but it is sort of Harry Potter themed, but without directly referencing the Harry Potter. So it's sort of magical. There would be possibly some direct analogies to some things that happen in some of the movies, but overall it's just taking that idea, that sort of magical puzzle solving idea and kind of making it into an escape room. So here you're looking at a polyfiber cast cauldron, and there's an inscription on the front of it that was kind of dremeled into the polyfiber, and on the top of it sits a potion rack. So this was all made by a prop maker, freelance prop maker, and my job was to basically bring it to life with LED and some sensors. So in the middle shot, you can see there's a bottle standing on the potion rack, and the bottles had magnets in the base of them, and the potion rack had reed switches in the bottom of, or underneath some, I suppose there's little bits of perspex that the bottle sits on. I'll just move on to the next slide because you'll get a better idea. So I'm in the main area. You can see the reed switches just over the perspex, all connected up to a nano. And basically, once all of the bottles are in place on the proper kind of light reaction that was created with addressable LED started, and there was steam generated inside of the cauldron, and there was sort of a loud bubbling noise, a very kind of special effects. But just to the left side there, there's a bit of a close-up, and you can see I just took some really basic 3 LED boards to connect up the right amount of light to reflect up through the potion rack. It's unfortunate I don't have, because of sort of copyright, I don't have actual finished shots of any of these props. They're all work in progress. And also, if you can imagine, like the escape room business wants to keep everything as secret as possible. That's why I'm not telling you who it is or where it is. So that I suppose the people that come into the room get the best kind of experience. They don't get to check out all the puzzles before they actually enter the room. So here there's basically 5 items that would have been placed in different places around the room, and the puzzle was to kind of bring them together and position them in the correct place. So here the base of each item had a magnet embedded in it, and then the panel is kind of sat over a fireplace. So the panel underneath is actually a mantelpiece panel. And the reed switches that matched up with the magnets were underneath. And we got around the issue of a kind of all 5 switches being on in sequence by just the magnets were positioned in a different position. So you couldn't put the cat in, say, the middle one and the puzzle working correctly. The cat had to be in the far left.
So they were all keyed in a certain way.
In sequence. Yeah, essentially. So so there was no programming involved in that. It was literally just positioning the magnet in a position and matching it with the sensor. So here, this is a puzzle. This is a 16-piece puzzle, same principle as the last prop. Leonardo for this one. Was a lot of soldering, a lot of wire, a lot of trouble to get this one working. And actually, in hindsight, we should have done this with Hall effect sensors because it would have been much easier to do. The magnets were far enough apart that you wouldn't have gotten a signal from one Hall effect wouldn't pick up a signal from another magnet, because of the positioning, the range, they wouldn't have been in range. So it would have worked much better. We had a lot of, because of the moving around of heavy pieces of wood, you're getting a lot of flickering on the reed switches, and that was kind of throwing the prop off. So getting around that one was kind of tricky. This was the way the room worked. There was kind of a hallway there that the players came into, and they had to open a door to get into the main play area. And one of the props in the hallway was this magical fuse box. So the idea here, I'm just going to play this bit of video, was that all the players had wands, and they needed to all point the wands at the fuse box, and that the switch would switch magically up. So the way we did that is we took the fuse box apart completely, keeping only the switch, and there was a little servo put into the switch handle, and a Hall effect sensor put in. So when the magnets were pointed at it, the servo was activated and it switched up, and then that triggered other events in the hallway. So this is another really nice one, but caused a huge amount of trouble. This is a little statue that was sitting behind the cauldron that we saw earlier. I'm just gonna turn off the sound there. So it was the statue was positioned on a lazy Susan, and like in an ideal world, it would have been the path of least resistance would have been to get a very kind of heavy duty servo to move the statue, but we used a stepper motor and set up a kind of cog system and counted steps and all sorts of craziness to turn the statue around. So this little flower that you can see the guy was pointing to in the foreground. And again, this was a point with a sensor, a Hall effect sensor inside of it, and that triggered a sound effect. That actually triggered the lighting on the front of the cauldron, which prompted the players to move on to another game. And this is another interesting one to solve. As really nicely made profits. It's a hand. The hand is actually made of hard rubber, so it was a casting, and then it kind of carved up to make it look like stone. And then the dagger was actually a kid's dagger that was just dressed up to look kind of better than it was. So like literally bits of punched jewelry. Bent around it and then sprayed. And the idea here was to put magnets into the handle so that when the handle was put into the stone effect hand, that would switch on another game within the room. And again, like one of the things was, I can show you probably better on the next video, trying to get some level of accuracy with where the magnets would stay, close to the sensor. You can see the dagger kind of moved quite a bit within the hand. So what we did is we actually just put 2 magnets in. It was the easiest way, one on each side. And I kind of built up a little bit inside of the hand so that made it more difficult for the dagger to move around, and that kind of solved the problem. Sometimes it's not an Arduino problem, it's kind of more of a physical problem. This was this was another headache. This is a scroll cannon, and the idea here was, sorry, again, the sound's on, I'm just going to turn it off. The idea here was that these white PVC tubes held paper scrolls, and the Uilleann pipe section here was basically an air chamber, and the blue thing was a pump. And this is like a solenoid activated valve. It's the kind of valves that are often used in for garden sprinklers. So if you want to remotely activate a garden sprinkler, say on a golf course or something, this is the kind of solenoid valves that they use for water. So in this case, we were using it for air. And initially, we were going to have this kind of gun barrel idea where the PVC revolved around and there was going to be a servo involved to move the PVC. But we ended up just buying a couple of the valves and setting up separate tubes. It was just way too much like hard work to get the servo moving the barrel around. If we had more time, we probably would have done that. This was one that you did a lot on, Jeff. I don't know if you want to talk about it yourself or.
Yeah, sure. Yeah, I can talk about this. So this was a whispering frog initially. In the prototyping stage, we had the lovely voice recording of Louise whispering spells out of it as we practiced. But it was quite interesting. So as Louise had said, it was a very much a time-constrained project. So we really had to use what kind of materials we had on site. So that means even the electronics. So we were using Arduino Nanos, and up until the time I didn't realize that you could play audio from such a low-powered microcontroller without kind of serious kind of additional circuitry. So I managed to code up using a great open source library to play a little WAV file, but of course it didn't play it loud enough to be in a to be in a kind of the environment that the escape room would be. So I believe it was Gary who did a rough sketch out of, oh, you need an amplifier. Here's the amplifier I learned how to make years ago. And with a back of a piece of paper, he managed to sketch out the components needed off heart to do a rough Class A amplifier that you see in the bottom there of the photograph. And then we had the audio source then at the right volume. But I guess one of the issues that Louise was kind of mentioning along the way is that it's very hard when we were building these projects. So all the kind of props and stuff were built individually, but then there's micro adjustments that need to take place when the prop is in situ. So for this one, it's a good example of the volume. So you have to build in a volume switch so that we can know the acoustics of the room, so it's not too loud and it gives away the clue too easy, and it's not too quiet where the average person won't be able to hear it and eventually won't be able to get out of the escape room. So yeah, it was a good kind of example here of one of the props that kind of had all the complexities and the time constraints of the project. But what made it great was, so after I had the coding done, someone was on hand in Tog that had the knowledge of how to quickly design an audio amplifier. So there was no need to go and do the research, and we could complete the project in that evening.
Yeah, well, thanks a million, Gary, for that input. That was great. So this is another one. This was a goblin that was made from like a little statue. The head was cut off and left to the side, and magnet embedded in the head and reed switch into the body, and kind of covered over and dressed up. And the final prop looked pretty close to what you can see in the picture on the right. And then the globe is basically a perspex globe that's been sprayed with metallic finish on the inside, and inside of that there was a kind of mask with some LEDs behind it. So when the player put the head on the goblin, the light switched on behind the mask, and a clue was revealed to move the players on to the next task. This is a pretty simple one. It's like a plaque that was essentially a switch. So the little brass oval underneath the inscription, when it was touched with one of the wands that the players are holding, triggered a banner to drop down in another position in the room. This was quite an interesting project, or section to the project. So this was the doorway between the hall, kind of passageway, and the main play area. And in the center of the play area, in the center of the door, there was a switch. I showed some LED earlier on in the slideshow of a kind of an LED circle with a kind of a slow chase happening. And what they wanted was a sort of glowing effect from the center of the door. And when the wands touched that, there was some LED around the door frame that was triggered to show some panels, some touch panels that were triggered with capacitive touch. So I made some little, basically just copper tape on paper that could be pushed into the back of the stone molding, and the client at their end chased the wall. You can see there the sort of a track for the LED to go in, and we just programmed the LED to, once the wand touch happened in the center of the door, the LED was triggered in the wall. And the next one is a prop that was kind of in the middle of the main area, and it was a tree stump that had a kind of a sliding drawer inside of it. So this was a major headache for me that was solved in a very easy way by the client in the end. I had planned to have part of the brief was that the drawer was to move very, very slowly and silently, so that the players hadn't any kind of idea of what was happening mechanically within the stump. So I spent ages kind of measuring steps on the stepper motor, trying to get the quietest stepper motor I possibly could, and then what the client ended up using was a maglock for doors, which is very loud, but it did the job. It literally, I mean, it was kind of a strong magnet, strong electromagnet that literally moves. There was a magnet on each side, and they could trigger the maglock, and the drawer would move towards the magnet. Very simple, but very effective. And that's kind of it. There were a few other props. Fortunately, I didn't take photographs of everything, but yeah, it was great fun. A lot of late nights, but great fun, and very glad to have Jeff's skill and Ben and help from Brendan and loads of other people in TOG as well. Kind of jumped on board and got stuck in. So that's kind of it. Jeff, unless you want to add anything.
No, yeah, it was a great project of... You came with a very kind of structured these X number of props, and there was plenty of different kind of jobs to do, and it was a great kind of method of working together. So there was individual projects, and there was that needed to be done to make the whole better, and then there was certain props that needed multiple people. So yeah, it was a great way of working, and yeah, it'd be great to do something similar again, but maybe a little bit more lead time.
A bit more organized with less time pressure.
Yeah. Okay, thanks very much, Louise. We're going to jump back to our slideshow for just a moment while I turn on the group call for the Q&A. So if you just all hold with me just a moment. And welcome back, everybody. We have our 3 speakers tonight. I see Louise got a camera working, so we're all ready to kick off. So if anyone has any questions, please put them in the chat box below, and I will read them out to each of our to the relevant speaker. So first up, we have a question for Brian about does he feel that there's a difference when playing an acoustic instrument like a guitar where you can feel the sound versus a digital instrument?
Yeah, there is a difference. Yeah, good question. I suppose that's actually with a digital instrument, there is something kind of a bit dead about it, maybe, and that's why I concentrate mostly on analog electronics, which I think have more. Although those are digital chips that I was kind of using them in a analog way. There's no computer, there's no microcontroller, you know. It's not sampled at all, so I try and keep things alive by avoiding digital things. But I think with the instruments I'm playing, it's different. I think it sucks you in because it's an unusual mode of playing it. Like when you're playing music, you've got a keyboard or you've got a guitar, and these are kind of typical ways you learn music. And then when you have something like that, you're like, what the hell is this? You know, this is a new way of making music. There's no keyboard. It's unusual. And that's kind of inspired by the West Coast philosophy in synthesizers, which took off like in the 60s when Moog was famously inventing musical synthesizers, that a lot of people thought, no, these are not a keyboard instrument. These are a totally new thing. That idea, because that ties it in more with the acoustic, like playing a guitar, and makes it more like that. So yeah, there's a difference, and I try and align them as much as possible. You know?
Okay, I have a question here for Bobby. It seems this comment here is about during your talk you mentioned the difficulty in getting people to record what they have repaired. Why do you think that is? Do you think that people are too busy, or people don't like filling out forms, or why do you think we don't have data on repairs?
Well, there is a reasonable amount of data that happens in repair cafes, but I think one of the things that's difficult about it is 2 things that are difficult about it. There is a repairer and someone who is in need of repair, and you want to tell them what's going on and help guide them through what you're doing to their product or their device or whatever it is that you're repairing for them. So your attention span is really directed to that person. So, and obviously to the act of repairing something. So it's hard to kind of task manage that. Addition to that is that the environment it's sporadic. Repair cafes are they sometimes happen in maker spaces, or like in the image that in the presentation, they're in local kind of community spaces or a pub or something like that. So people just come along with a bag of tools and they set up, whether it's their multimeters and special hex keys or pentalobe screwdrivers and things like that. And that's what they have with them. So it's a chaotic environment that they're not sitting next to a computer or a laptop or an iPad or something like that. Yeah, so it's a difficult environment, and one of the things that we've thought about when we're mapping this out is, okay, the person's getting something repaired for free usually in a repair cafe. Can they enter the data? But then you get the issue of looking into taxonomies on how to class something as a repair, or what type of repair or the fault. So it extends the issues of data cleaning as well. So there's a few different issues within the confines of that problem. Okay. But I suppose that's what we're trying to do with this tool, is to try and make it a bit easier,
Okay, next question here is for Louise. Someone is interested in the design process when it comes to the aspects of the escape room. Do you start off with a puzzle idea, or is it starting off with spotting a nice looking prop, or what sort of is the design flow in that?
It can be anything. I mean, I know. I wasn't involved in the game mechanic design, and that it would be so much better if I was, because you can come up with so many more ways that something can be done, if you like, as a designer with, I suppose, some understanding of Arduino and mechanics and stuff like that. So the way it worked in that particular project, we got a script of essentially the gameplay, and the main prop maker made all the props and then kind of engaged me to make them go, so to speak. And it just works so much better when everybody's involved from the start, because you have kind of more of a collaborative process. I guess from the client's perspective, they wanted to kind of have some level of control over the process, and quite often having a kind of very clear script, it sort of can limit costs to an extent, but we ran into a lot of problems trying to solve mechanical issues that, if we were there from the start, wouldn't have happened, I guess. So yeah, just collaboration from the start would be what I'd recommend.
Okay. I have several questions for Brian that I'll kind of merge into one. A lot of people want to know is, do you play live gigs, where they can see this, and when can they see you next play? It might be a bit hard now with the current situation.
Good question. Yeah, I'm dying to get out and play. Yeah, I do. I mean, I was a professional musician playing regular music, if you like, before, but also doing sound art things. I mean, I played, there's a sample studio, there's an artist studio in Cork here, so we did some shows for them, like exhibition openings and closings. There's what else is there? There was a cool place, Zolala, was a really nice night where they used to show films and have artistic talks and stuff, and all sorts of great activism and art. So he played some performances there. I'd even, a friend of mine, Jesse Holloway, shout out to him. He's a great sound artist, and I took that guitar I was showing you, the synth guitar, to London with him and played at the Chelsea School of Art. So yeah, we were doing things, and in the future, hopefully, there's another place, the Guest House in Cork, which is a sort of centre of experimental stuff and sound art, and that's probably likely where I'd hope to be doing a show soon. So yeah, keep an eye on the Guest House or Sample Studios, and hopefully see you soon for a live show. Yeah.
Oh yeah, it'd be great to hear some live music. Next question is here for Bobby. Some people, this viewer is questioning this the repairability index and how it's made by the manufacturer, and this whole idea of self-policing. Is that possible?
It's definitely a good point. I think that the French repairability index score, it being manufacturer built, is not really ideal. When you compare it to something like the iFixit score, iFixit, they tear down products all the time. They have a great site where they do reviews of brand new products and how repairable they are. And their repair index, they actually assisted on the development of the French repairability index. So like the actual structure of how the index is done is really, really quite well thought out. And it includes the availability of parts, not just how easy it is to get into the part, and how difficult it is to take things apart, or if they're all glued together, or if there's 20 small things you need to take out in order to get to let's say a camera, for instance. But it's not ideal that the manufacturers are actually self-scoring. It is ideal that the government have a mandate, or it's mandatory to actually have that information. But the structure of the repairability index is actually the way that the score is calculated. It is quite difficult to actually jostle your result, although if you're going to be completely scathing, you could do it.
Okay, we have another question in here for Louise. During your talk, you mentioned reeds and Hall effect sensors. Have you experimented with any other type of sensors in puzzles?
Yeah, proximity sensors and infrared. There's so many different types of sensors you can play with. Like a lot of things, a lot of gameplay can be purely mechanical as well. Like you don't need a sensor all the time for games to work. I mean, pulleys and levers feature kind of heavily in escape rooms as well. So it really, some stuff can be very, very simple. Mirrors, smoke and mirrors. It's always good.
All right, I think that's all the questions that have come in. I think I'll go around the table here one more time and let each of our speakers tell our viewers where they can find out more about their projects and about themselves. So if we start off with Brian.
Yeah, corkguitars.ie is probably the best place to check out what I'm doing, and Cork Guitars on Instagram as well. I tend to put up a lot of stuff on that. My email address is info@corkguitars, so ask me any questions, or if you think you can help out with the stuff I've been talking about, I'm all ears,
Okay.
Thank you.
And Bobby, where can we find out about yourself and your projects?
Well, the projects run out of UL, so you could look at the design factors for that aspect of the research aspect. But the right to repair, repair.eu, is where you can sign up to engage and list your interest in repair activities. Or you can look at restarters.net, which is a UK-based partner on the project who have a huge amount of just news and activity and updates, and a brilliant forum for anybody who has any repair-related questions. There's a huge amount of people on there that are really enthusiastic and willing to help you with whatever problems that you might have.
Okay. And finally, Louise?
Well, you can get me on Twitter and Instagram at Louise Lucid, and I have a website which is primarily kind of my design work, louisenolan.com. Needs some updating. It's always the way. I'd say the social media channels are probably better for more current work. Say hello. I'm always curious if anybody's any questions. Just ping me.
Okay. Once again, thanks to each of our speakers for giving up their time tonight and sharing their projects with our community. Thank you.
Thank you.
Bye.
So thanks everybody for tuning in to our night's set of talks. You can share this link with your friends if you would like to share tonight's talks. They can watch them back there. Just a few more shout outs to things going on in TOG. So just another mention of the Double Maker Open Call that's going on at the moment for the big event in June. The open call runs until next Tuesday, so they're looking for all sorts of submissions. Other things is during level 5 restrictions, unfortunately our space is closed, but we have plenty of virtual events happening mainly on our Discord channel. So if you check out our website or our meetup group, you can find all about our book clubs, the Wikipedia editing night, our coding nights. There's craft nights now on Sunday evenings. It's a great way to wind down your weekends. All that sort of information can be found on Meetup or else on our website. And finally, our next live stream event will be Raspberry Pi themed. We had great success earlier in the month around our Arduino theme day. So if you have any Raspberry Pi projects you'd like to share with the community and come on here to give a short talk, please get in contact with us via email at info@tog.ie, and we'd be happy to showcase you and give you that opportunity to tell us all about your projects. So just to say it again, next month will be a Raspberry Pi themed stream, so please do get in touch, and you can find out about and get notified about our next stream if you click subscribe, and you'll get the notification when we put out the dates for our next stream. So thanks again to our speakers, and thanks to everyone for coming by.